Assalamualaikum dan salam sejahtera. Okay. In exercise 5.2, I would like to demonstrate to you how to apply the simple linear regression model. Okay. So number one, okay, there are two questions from exercise 5.2, but I will only discuss number one. Okay, a study is conducted to investigate the relationship between the cause of fire damage and the distance between the fire station and the location involved in the fire accident using regression method. Okay, so the data is given as follows. Yeah, so these are the data, the cost RM million and the distance in kilometer. Okay, so in part A, identify the independent and dependent variables. Yeah, so we need to determine whether cost or distance is the independent and dependent variable. So which one? Okay, so in this question, okay, normally the cost is the effect from the distance. Yeah, the longer the distance, yeah, that means the cost will be more because fire engine will take more times, yeah, to reach the destination or the affected area that is on fire. So the cost will be more. So in other words, distance will be the independent variable, this is X, and the dependent variable will be the cost, Y. Okay, so that is part one. Okay, for scatter, draw a scatter diagram and give comment. Okay, so I use the other one. Okay, B, to draw the scatter diagram. Okay, so you can plot. So basically, if you plot this, yeah, roughly, so I use Excel to draw this, you get this something like this. Okay. Okay, what is important is how to interpret this. Okay, so from this you can see that X is the distance, okay, and Y is the cost. Okay, so we can see that as X increase, so has the cost. Yeah, in other words, there is positive trend. Yeah, positive trend, or we call it upward trend. Upward trend. Yeah. Yeah, so the data has an upward trend. Yeah, so has X increase, so has Y increase. Yeah, when the distance increase, so has the cost will also increase. So that is how you interpret or describe the data. Yeah, from the graphical representation. Okay, in C, you need to calculate all the sum. Okay, this one you can use your calculator, but I just give you the value. Sum of Y equal to 338.7. You can check this later. Sum of Y squared is equal to 10197.17. Sum of X equal to 43.6. Sum of X squared equal to 180.02, and sum of XY is equal to 1342.57. Okay, so this is the summation. Okay, you will use this value, yeah, in part D to calculate the correlation coefficient, where you have to calculate SXX first, SYY, and SXY. Okay, so I give you the answer first, 2.21.6067, SYY 637.3625, and SXY 111.96. Yeah, so R is equal to 0.9541. Okay, so this is the value of R, the correlation coefficient. So how do we interpret this? Yeah, so this is our correlation coefficient. Okay, so since this value R is greater than 0.7, so that means we have positive, we have strong positive linear relationship Yeah, linear relationship between cost and distance. Okay, so that is how we interpret. Okay, and then E, you need to find the correlation coefficient of determination. E, coefficient of determination. Yeah, where it is this is from 5.1 actually, which is R squared. So you will get equal to 0.9103. So you can interpret that, change to percentage, 91.03% of the variation, yeah, in the cost, yeah, that is Y, can be predicted by the distance. Yeah, the distance of the fire station, yeah, distance, which is X. Okay, so that is how you interpret coefficient of determination. Then from there, you need to estimate the, find the coefficient and find the fitted regression line or predicted regression line. Yeah, predicted simple regression, simple linear, yeah, regression line. Yeah, where you need to find y bar, y hat equal to beta naught plus beta 1 hat x. Yeah, where using the formula you can find beta 1, yeah, equal to 5.1817, and beta naught, yeah, using the formula that we give you before, 9.3983. Okay, and hence you can write your equation become 5.1817 plus, sorry, the other way around. Okay, so you can write that beta y hat equal to beta naught, which is 9.3983 plus 5.1817. Okay, and then the question also asks you, so this is the best fitted line. Okay, okay, E, F, this one should be F. Okay, G, okay, part G. Part G is give the interpretation of regression constant and regression coefficient. Okay, how do you interpret beta naught? So you can interpret beta naught, which is equal to 9.3983. Okay, that means the predicted cost is the predicted cost of fire damage, yeah, is RM 9.3983 million, yeah, million, when the distance is 0. Okay, so for beta 1 hat, which is equal to 5. This one should be X, 1817. That means the cost of fire damage will increase by 5.1817 million, yeah, for each unit of, for each kilometer, yeah, for each kilometer distance. So you can write that, yeah, because this describes the slope, yeah, slope or regression coefficient. Okay. Okay, and then we continue. So in H, it asks you to estimate where the cost when the distance is 10 kilometer. Yeah. So we have this equation, y hat is equal to 9.3983 plus 5.1817x. Okay. So we need to predict the when x equal to 10, yeah, that means the distance, okay, is equal to 10. What is the cost? What is the cost? Yeah, what is the cost? So what we have to do is simply substitute x equal to 10 into the formula. Plus 5.1817 times 10. So you will get equal to RM, yeah, 61.2153 million. Okay, so that is how you do it. Okay, in I, you need to predict the distance when the cost is 10. Yeah, so when cost is equal to 10 million, yeah, cost is y. Okay, so what is x? Yeah, what is x? The cost. Yeah, when we want to find the distance when the cost is when the distance when cost is 10 million. Okay, so what we have to do will be to substitute to find x when y equal to 10. So what is x? So you can find x is equal to 10 minus 9.3980 divided by 3983, sorry, divide by 5.1817, okay, which will give you 0.1161. Yeah, maybe I need, okay. And the last one, J. Okay, J is what is the mean cost when the distance is 20 kilometers. Yeah, the mean cost. So that means we want to find x bar, or you want to find y bar. Yeah, y bar, what is equal to when x equal to, what is the mean cost? Sorry, we want to find y bar when x equal to 20. Okay, so for this question, yeah, it's simply the cost is simply equal to, the mean cost is simply equal to RM 28.225. Yeah, so the answer is always, for whatever x, the answer is always y bar, the mean cost is always equal to this. Yeah, because since our regression line, it passes through this point. Yeah, x bar, y bar, so it doesn't matter what is x. So we can show this numerically using mathematics. Yeah, okay, that's all. Okay, and I leave question number 2 for exercise 5.2 to try, for you to try. Okay, it is exactly the same. Okay.